Now we have here another set operation, and that is the difference between sets, or the relative complement of a set. So what is set difference, or the difference between sets? So if we have two sets, A and B, so the difference of A and B, denoted by A minus B, is the set containing those elements that are in A but not in B. So the difference of A and B is also called the complement of B with respect to A. Writing the notation of the difference of A and B, we have A minus B contains X, such that X is an element of A and X is not an element of B. And we have here the Venn diagram for that. So you can see the shaded region, or the shaded part, are the only elements remaining in A. So it means that all the elements of B are taken out or subtracted from A. Now let's have an example for that. If we are given two sets, we have set A containing 1, 2, and 3, and set B has 3, 4, and 5. So if we have A minus B, or just the same as all the elements of B subtracted from A, so we have to take all the elements of B from A. So the remaining elements will be only 1 and 2, since we are to get 3 from A, and 4 and 5, since there are no 4 and 5 in A, so it doesn't matter. So the remaining elements are only 1 and 2. So if we have here B minus A, it means that all the elements of A are taken out or removed from set B. So let's have here 1, 2, 3. Let us take that from B, which has 3, 4, and 5. So we only have to get the 3. So 1 and 2 is not in B, so it doesn't matter. It doesn't make any difference. So the only remaining elements are 4 and 5. So now if we have to take the elements from itself, or the elements of set from itself, we have set A minus A. Then we don't have any remaining elements, and that's why we have an empty set. So same thing with B. If we are to take all the elements from itself, then we don't have any remaining elements in our set. So we have an empty set. Now let us represent those two sets using Venn diagrams, so you may have a clearer understanding of the difference between sets. So we have here sets A and B. Again, we have set A as 1, 2, and 3, and B having 3, 4, and 5. So they have common elements, which is 3, and that would be our intersection. So let us put the number 3 here. And the other two elements, 1 and 2, it is still inside A, and 4 and 5 is in B. So let's see. A minus B, meaning we have to get all the elements of B from A. So with our Venn diagram, we have to get all the elements of this region from A. So 3, 4, and 5 is included in B, so we have to take that, and the remaining elements will be only 1 and 2. So we have here 1 and 2. So now we have B minus A, meaning we have to subtract all the elements of A from B. So we have here 1, 2, 3 as our elements in A. We have to get that from B. So we have to take all the elements of this set A from B. So our remaining elements will only be 4 and 5. So that is our B minus A, 4 and 5. So if we are to take A, or all the elements of A from itself, if we are to take 1, 2, and 3, then we don't have any remaining elements. So our elements, or our set, will be an empty set. Same thing with B minus B. If we are to take 3, 4, and 5 from B, then we don't have any element in it. So our set is an empty set. So do you have any questions? So if there's none, I would like you to have these exercises to be answered in your notebooks.